So this project here, Scott and I were working on in the computer science department, trying to do an independent project, and we're still trying to push it through and also get a company to let us do some of this analysis we want to do. But the main topic is Social Security, but not the Social Security like everyone else knows about. So obviously there's the three different types of security: physical, which everyone is well aware of; technological, which most of you guys have experienced a lot of that too. But then there's a social aspect. And there's social engineering, but this is a little different because it's dealing with more public shared information that people put out there and how it can be used against you. So this is basically identifying. We're not talking about the Social Security you really know about. But as far as publicly shared private information, your background, pictures, and personal identifiers are all over the web, whether you like it or not. But most of it's because you put it out there. So criminal intelligence, this is how law enforcement and the military looks at criminal intelligence. Information compiled, analyzed, and or disseminated in an effort to anticipate, prevent, or monitor criminal activity. But in turn, people can use this same type of analysis for personal and or corporate activity. So when we pitch this project, we're trying to bring this to a company and say, look, we can look at what your employees do, what kind of information they share, what kind of policies you guys have in effect to help restrict that type of publicly shared information because you got intellectual property and or whatever type of business they're involved in, how it can affect people in general. So there's stages of criminal intent. You obviously got recon, mapping, discovery, exploitation, and post-exploitation. What we're really focused on with our project was the recon, mapping, and discovery. Recon NG was one of the exhibits for the DerbyCon in Louisville, and it seems to be pretty powerful in terms of just grabbing and querying databases, but it's actually querying databases that have been built from other databases over a long period of time. And they actually have a lot of information, a lot of access that way. So originally we didn't have that tool. We were going to go out and actually seek out, based on the information we knew, and do more searches to find more additional information. And this just makes it easier because it does it for us. And the other program we were going to use to help analyze the data is called Gephi. And it's a statistical open source software that looks at cluster analysis. So I'll show you the software here in a little bit, but basically you can take your whole Facebook network, put it in there, and do algorithms and run it on there and see exactly how the network interworks and all stuff like that. It's really actually interesting, but you have to tweak it to do what you really want to do. So like I said, the initial stages for the reconnaissance, Recon NG, we're planning on using that, and basically trying to get the topography of the whole company, like who works where, what departments might exist. And for the project itself, we were just going to plan on meeting with an HR rep so that we wouldn't violate people's rights within the company and the company wouldn't be pissed off at what we did so they actually know, and maybe a security person with an IT or something like that. And then we didn't want to know any additional information. Everything else we want to find out through the company's website, social networking, everything else, and see what we could access and what we could tell the company about itself and its personnel. And just to show how much public information is there and how you can exploit it to find more information out or put things together.
And the nice part about with our mapping and discovery, apart from the last phase of discovery, when we use a Metasploit framework to see what they have and what they're running, everything else that's done never even touches that company's server or network. It's all external, so they really have no control over what information we access or gather. It's all from social media, databases that have stored that information and other sources. So it's actually the company's really never even touched up until the Metasploit and exploitation phase.
So when we were pitching this to the companies, starting goals, we wanted something small because there's going to be a lot of data we're thinking, obviously, with social networks and how many people share that much information. So we wanted a small, medium company, local. And then we were looking for information about the company as a whole and the employees that work there. And then for the company itself, we're looking at the topography, which Gephi kind of helps, and also identify some other things as possible weaknesses within their social structure and or other stuff, depending on what we want to put in there. And so then we, based on some other information, we can also get access structures in terms of what kind of policies they have in place. Even like if we can figure out just usernames, how they structure that, then we can basically, if we know what people work there, we can take their name and make the username out of it and all sorts of things. So you just get a bunch of information from just a few bits of pieces of information as long as you look at it intelligently. So employees, obviously we're looking at all the social networks most commonly. And the one that I think is actually the most interesting is LinkedIn, which we talked to Jeff about as well. Is it's probably one of the most truthful social networking in some regards because people will use it to get hired. So when you want to look at who works for the company, what position, what they actually do in the company, I mean, most of it's right there. And so all the other social networking where you're just kind of socializing and you can see who's got strong social interactions and whatever, that one professionally shows a lot of information itself. And then as far as liabilities that lie within these social networking and finding information about the person, I was in the military, so a lot of my background as far as clearances go as well, they'll always look at liability. So how much debt you have determines whether or not you can do specific jobs. And that can be used against somebody as far as trying to get intellectual property or other types of access. So yeah, that would be a vulnerability when you look at people's background, how much debt they acquire, the liens they have against them. Address and locations, most of you probably know that you can pull GPS cords off pictures. It's stored in there unless you turn that feature off. So you can even just figure out where they commonly travel, what common routes they might take, what access they might have to, depending on what kind of pictures they post and stuff like that as well. And a lot of people don't know this, and you think about most of the people, depending on the company, they might be technologically savvy. I mean, you still run into people who don't know how to use computers very well. So, I mean, you can imagine how much of a vulnerability that can be proposed to the company. So, our ending goals was really to assess what the true vulnerabilities were in a company, because since this hasn't really been done to this degree, you really can't really say what is a true vulnerability and what isn't. So hopefully, if we get to work with a company and we can start pulling just as much data and looking at it differently, we can actually identify these exploits, and then figure out what's a good scale, because obviously a company can't go completely private with their information and function depending on the type of company. They have to have some publicly shared stuff in order to operate and get their name out there and advertise and everything else. So finding that balance depending on what kind of company it is, and determine policies that need to be in place. So the other idea we're having as well, depending on what kind of companies we had that were interested, was maybe comparing two different companies that had one a really strict policy on social networking, public shared information, and one that had a very loose policy, and compare how much information is actually shared, how many people actually share stuff, depending on what company they actually worked for. So that's just kind of a rundown of the project we wanted to do, and I'll show you kind of some of the stuff we were looking at in terms of using this Gephi software. Wow. What we're looking at right now, this is just the computer science and chemistry department in DKU as faculty and classes. The cool thing about Recon NG is the reports that pull up can be, it's not CSV files are reported in CSV files. So I always say CVS for some reason. It's just because I hear it all the time. Yeah. So we can take that information and directly put it into this. So it's basically like your standard Excel spreadsheet. And what you're looking at here are nodes that you just saw in that diagram. And they're either people or their class, and you can put all this other additional information because it can look at that as well in terms of how you want to graphically show it. So, I mean, you can see you've got all the chemistry classes that are offered, who teaches them, where they actually teach, how many days a week, and all that kind of stuff, which can be very pertinent depending on what you're trying to do as an attacker, or what kind of attack you're actually trying to implement. So, when you look at this, it randomly places the nodes because it doesn't really affiliate what's what, but it can actually run some algorithms to identify things. So one of the algorithms that we will run is called modularity, and this helps identify communities within that network or massive network you just pretty much put there. And all the edges are connected based on how people would interact, or their names associated with a class. So boom, they're going to be edge to a class. And you can actually assign weights to those edges depending on how strong that connection, depending on how you want to go about assessing that, and then run other algorithms to identify more things. So we were running. If I reduce this number, it just basically tries to identify smaller communities as opposed to larger ones. So it helps break that up. And it breaks it down. It says there's roughly 24 communities within our graph here. So it takes that information and actually applies it to our data laboratory. So now you have a category, which you can't see because of the way this resolution is set up, but you have a modularity category over here. And now you can look at this and apply that. So now you got kind of a color scheme to show who's related to what. Well, the other cool thing about this thing is visually, you can actually see the communities by changing the layout, and it runs an algorithm based on strength of association. and it immediately breaks it apart. So now what you're looking at here is the computer science department is smaller than chemistry. So this is obviously computer science, and I can actually turn on the labels, which right now the scale is kind of hard to read any of that. But here's the deans of the departments that basically connects both those. And all this is pulled off 3 different EKU sites, this information. And so now, just as looking at if this was a company that you wanted to attack, either like a physical malicious attack where you're trying to, like terrorism type stuff, or maybe trying to exploit something because you're a competitor, you can see who has access to what, who interacts with who, how departments might be set up. And if you get, say, maybe a project name that people might be associated to, you can say, oh, well, if this person works on this project and they're socially linked with these other people, then now these other people have access to the same project. So then you might be able to exploit how to get more information about that project even by going through maybe a weaker link by someone that has a weak background or something else. So you can see how that can be exploited. And the other cool thing that we can actually look at too is you can see how it breaks things up percentage-wise in terms of information in the communities, like how big the community is compared to everything else. There's filters you can put in there. So if I can find, for instance, the attributes. So we want to look at, I'm going to put a filter in here because I'm going to look at the days of the week. So for instance, we'll do that, and then maybe the department, we'll look at, actually, I'll get rid of the department. I'll put that one out. So we'll just look at just days of the week. So if you're looking at just the days, and I run this filter, I can then look at the days here, and it will basically show me, percentage-wise, what days have the most classes. Maybe you can exploit that in terms of, well, if you're going to do a physical attack, it's like, well, Tuesday, Thursday is 21%, but Tuesday is also 20%. So that means on a Tuesday, 41% of the classes occur. So there might lie a vulnerability there in terms of if someone's going to do an attack, that'd be the most effective attack. You look at it from that standpoint. So people can gather just this public information and really start to plan something or coordinate something that could be potentially effective. Or you can also look at the days and the location. So now I can filter it based on location and see what it shows up. So 10% of the classes between the chemistry and computer science are in the science building, room 5101. So you can figure stuff out like that. And that's just basically pulling that raw data, and it looks at different categories, does some cluster analysis. You can find those things out as well. So you can see how kind of scary this could be just based on public information alone. And even some of the other statistical algorithms you can run, for instance, if I were to run hits determines where hubs of information might be and identifies authority as well. So who might actually hold a position that actually has a strong authority within a group. So I can do it based on, I think this is size. So now I can do this based on authority. And now you can see it shrinks these down, but based on the size of the node determines how much authority that node might actually have. And it identifies one of the deans as the stronger dean compared to the other two based on connections. So you know there's actually a head dean. And you can see how it breaks up the classes. Obviously classes aren't going to have much authority because they're not really an authority figure at all. But I mean, some of this visually you can see, but you can see if you had a really, really large network and you didn't have every single node, it still might help you identify those specific things. We can do the same thing for hubs. So we'll hard to see. So now you can see where hubs information goes. Another cool algorithm that is kind of interesting is PageRank. It basically tries to, based on the edges that exist, identify. It randomly determines how often a node might get hit based on the edges that exist in the diagram. So then you can see information flow. So you can see, okay, if I'm trying to find this piece of information, who gets access to this information most based on social network alone? Who interacts with the most people based on, and then you can run filters to try and isolate and pull people out that you know aren't important, or pull places out that aren't important. So with all this type of analysis, you can see that there's a lot of vulnerabilities that people don't take into account. especially when they're just putting on, hey, I'm going here to hang out this location, meet me up there, or man, today at work was tough, or I gotta go in late at work tonight, and all of a sudden you're identifying maybe patterns in which hours people work, where they might be, as far as their background information. And if you share anything about the company, how does that information actually hurt a company? Just basic information. So that was the scope of our project. We did present it to the board of advisors of the computer science department and scared most of them to death. I didn't present it as aggressively as I did to you guys because obviously I was trying to pitch a sale as opposed to just trying to throw out information. But they all were very, very interested, but they were just too scared to think, well, what's the PR repercussions if they do the study with us and they find out students are looking at their employees' background information? which is completely understandable, but that brings up our point. If they're not sharing this information, they shouldn't really be worried. So we do have one company that's interested. We haven't actually physically met with them because we want to do face-to-face, because I figure an email over the phone, this might sound a lot worse than trying to explain it in person and showing at least something like this. But that was pretty much the scope of the project as far as Social Security goes.
So did you create this program?
It's open source, so I didn't create this specific program, but we have talked about possibly implementing some other things. So if we can't actually do a company's analysis in terms of their employees, we might write some code to randomly generate certain things as far as field goes and what social networking sites offer, and help us build a fake diagram that we then analyze and see what it could highlight, or to try and learn what vulnerabilities are. But as you can see, that'd be really hard to do when there's no study information that identifies any of this. So.
Yeah.
And we also plan to do it ourselves just to, I guess, get used to it or try and rank specific attributes or vulnerabilities that we're specifically looking for.
Yeah, one of the things I want to figure out is coming with a point scale system based on these edges. Depending on every kind of social interaction we find with one node to another, how we can increase and bump up that edge weight based on the type of relationship that might exist and the interactions they have outside of work, inside work, so that you can start building where strong relationships lie versus weaker ones, and what exploitation that could be, or where more information can be leaked even if someone's not working with something directly based on interactions and stuff like that. So there's a lot of things that don't exist that we have to kind of figure out, come up with ourselves, but that's kind of the point of the project. So.
How do you get the initial information for it? Like just, do you go to like just type in Facebook, or how do you actually pull up the information?
Well, Recon NG, it uses APIs based on the databases that pulled information from those sites. And it basically gives you something that looks kind of like this as far as the report goes. So we can directly import that. Originally, before Recon NG, we were planning on going to Facebook, using Google, searching names, and then if we pull up a name and we pull up that information, then we search that information and basically see how far the information takes us and where it would, So Recon NG kind of shortens that for us to some degree because it hits a lot of at least the key points, but we're still going to have to do that digging deeper phase. And for every piece of information that we find, we're planning on screenshotting that shot, say this is where we found this information, this is where it's located, this is the time we found it. And that's the other cool thing of this program is we can actually do a dynamic build. So we can put a time on which the nodes were discovered, and you can dynamically see where we started, run it, and you'll see over time how it builds the whole network. So you can see how fast, basically how much time it might take for someone to do this, or see, then maybe if you look at just the time spread alone, you might be able to see, well, this department we found out really fast about over a really short period of time. There might be more people talking here, and it might help a company identify where their weaknesses, where they need to educate people, or what. So that's another thing to look at as well.
Well, Recon NG might not be as populated as that. I mean, we'll probably have to fill in holes, or we find information that isn't necessarily available through Recon NG. So I mean, we sort of plan on doing the entire check ourselves as well, but mostly Recon NG is a good starting point.
Just use that framework to work with. Because we have to do this within a semester, and that's why I want to start the project now, so that we can get this started, start gathering information, and try to analyze it by the end of the spring semester. Because we don't know how much data we're going to find, but we assume it's going to be a lot. And so, and if we don't finish it, then we get an F for the project. If we, maybe a huge waste of time, and it'd be very depressing. So, but any other questions?
Sorry. So are you going to do this for the whole campus or what?
No, and now I'm probably not going to do any more with the campus because one of the people was head of the IT department, Mona. She was very.
She got freaked out.
She was really angry that we even did this initially, and she was like, "Does the chemistry department even know that you did this?" Like, it was like a big concern. I was like, "Well, I mean, we've mentioned to some of the chemistry professors that we're working on this type of project because he knows a lot of them, but no, I was like, we didn't really." She goes, "Well, I think it's might anger a lot of people." I was like, "Well, then don't put it on the website. Like, that's the whole point, you know." So it's
So you can't really.
yeah, so it's validating basically our point, but I don't want to piss off a lot of people since we got that EKU to try and give us the okay on the project. So I probably will stop with EKU, but I might try some other things out. So, I think they even talked about how there's a way you can actually pull the network in your friends list and put it in here directly as well, and analyze random things and stuff like that. People found like dating schemes of who dated who based on friends, and and try to predict who's the next person this is going to date based on this social network and stuff like that. I mean, people do really quirky things that I've read about, but obviously I don't know this that well. I've only been working with the software for maybe 3-4 weeks now. But
That's pretty interesting though, because then you can even test the visibility, like how Facebook is selling, advertise this post or push this. You can actually see
they
the
run this.
visibility that a person can hold or a department can hold.
Yeah, and the same algorithms. I mean, they give you a reference of where this algorithm came from that they run on these things, and a lot of these are actually used by the social networking sites to push ads your way and stuff like that. So this is very commonly used tactics, just not in this way. So. Anything else? I guess that ends this presentation.
Thank you.